Hi, this is Sudha Malli, Assistant Professor, Department of Civil Engineering from Rohini College of Engineering and Technology, Kanyakumari. Today we learn about the global positioning system. Uh, the global positioning system in a worldwide radio navigation system from the constellation of 24 satellites and their ground stations. GPS uses satellites as reference point to calculate positions in meters and also centimeter. GPS plays a vital in cars, board, planes, construction equipments, movie making, here from missionary laptop computers. It is a most sensitive and useful tool in advanced surveying and mapping. With the help of GPS receivers, a radio-based navigation system is developed which is in turn ascertains exactly the three-dimensional position, inclusive of latitude and altitude of any point on the space. So there are three segments used in this GPS. First one is space, second one is control segment, third one is user segments. Space segments. Space segments will consist of 24 GPS satellites with an addition of 3 active spars. The satellites are placed in almost 6 circular orbits with an inclination of 55 degree. Orbit height of these satellites is about 20,200 kilometer, corresponding to about 26,600 kilometer from the semi-major axis. The nominal orbital period of a GPS satellite is 12 hours. The orbits are generally circular and spaced equally about the equator at 60 degree at right as the sun. This satellite constellation provides at 24 hours global navigation and time determination capacity. Each satellite sends a full description of its own orbit and an approximate guide to orbits of their satellites. Location of satellites are established by their own orbit data. So, at any given time, at least four of the satellites are above the local horizon at every location on there 24 hours a day. Then radio waves is equal to speed of light. Receivers have nanosecond accuracy. All satellites transit same signal string at same time. Difference in time from satellite to time received gives distance from satellite. The whole thing boils down to those velocity times travel time math problems we did in high school. If a car goes 70 miles per hour for 2 hours, how far does it travel? Means velocity multiplying by time is equal to distance. So accurate clocks. Satellite have very accurate clocks and very accurate abscess informations. Light speed is equal to 1,86,000 miles per second. Out of sync by 1 divided by 100th of second equals error of 1860 miles. Automatic clocks aboard each satellite. Then second one is control segments. So the main function of the control segment is monitoring and controlling the satellite system continuously, determine GPS system time, predict the satellite appearance and the behavior of each satellite clock, update periodically the navigation message for each particular satellite. It consists of a master control stations, monitor stations, and ground antennas are located around the world and operational control segment. The monitor station receives all visible satellite signals and transmits the range data along with the local meteorological data linked to the master control stations. Then master control system. Then Pre-computer satellite embraces and the behavior of the satellite clocks and formulates the navigation data. The navigation message data are transmitted to the ground antennas and via S-band it links to the satellites in views. This is the monitoring stations. Then the last one is user segment. It consists of the receivers we use. GPS receivers are required to receive signal from GPS satellite for the purpose of navigation of positioning. How many channels our receiver has? That means 12 channels. Single frequency receivers can pick up to L1. Dual frequency receiver can only receive satellite data, not transit data back to satellite. Then this receiver wise, some receivers are used: handheld receivers, geodetic receivers, single frequency, dual frequency. Handheld receivers, it's the simplest. It is a data recorder which may be capable of tracing up to 6 satellites. For differential work, this must be used with the MX800 and 650 base stations, which has the capability of tracking 12 satellites. Typical uses or assist mapping utilities would be permanently mounted at the office of depot. Then geodetic receivers, few of the currently available GPS receivers that are used in geodesy surveying and precise navigation are described. Nearly all models started at single frequency, that means C bar A code receivers with 4 channels. Later, L2 carrier phase was added and tracking capability was increased. Dual frequency receivers, survey grade receivers, are the top of the range of receivers. These receivers are precise relative methods for determining position and capable of performing static and or TK survey with the accuracies at the centimeter level. When they are within the range of each other, Bluetooth devices will detect each other and establish connect. Okay, thank you.